Hello everyone, this is the part 3 of lecture number 3 of unit 2nd on the ordinary differential equations. In the previous lecture, we solved non-homogeneous linear differential equation with constant coefficient, okay, when right hand side of the differential equation is polynomial of degree k, okay. And now we will here we will solve the differential equation, non-homogeneous linear differential equation with constant coefficient when right hand side of the differential equations means qx is exponential functions or the product of exponential functions and other function of x. So let's start case second. Here we have three cases. A, when qx is v into e to the power ax, and here condition is that pa is not equal to 0, okay. And case 2, qx is equal to v into ax where pa is 0. Here p is polynomial in D. When we replace d by a, if p is non-zero then we have case A, and if pa is 0 then we have case B. And one more case we have here, when qx is product of e to the power ax into function of x. Here v is function of x and here v and a are constant, okay. So we take some questions on case A. Case A, the particular integral of the non-homogeneous linear differential equations is equal to 1 upon pd e to the power ax, and this is equal to pa e to the power ax, and right here v is constant, so we can take it outside, okay. What here condition is that pa must be non-zero, okay. So we have some questions on this case. Question is solve the differential equation, and differential equation is d square minus 2d plus 5y is equal to e to the power minus x. So we solve this questions, this differential equation. It is clear that this is the non-homogeneous because the right hand side is non-zero, and here we have a exponential functions, okay. qx is e to the power minus x, and this is the linear with constant coefficient. So it is a non-homogeneous linear differential equations of order 2, okay. So to solve this differential equation, first of all we find complementary functions, and we know that to find complementary function we find auxiliary equations. This can be obtained just by taking m in place of d, m square 2m plus 5, and take it 0. So this is the quadratic equation. Using the quadratic formula we have minus plus 1 plus 2 under root b square minus 4ac 4 minus 24 upon 2. So this gives us 1 plus minus 16 4i upon 2 2i. Okay, so here we have, therefore complementary function means yc is, here we have two complex root alpha plus minus I beta. We take here alpha is 2 and alpha is 1 and beta is 2. So we write the solution like this. We take alpha e to the power x, e to the power alpha x, and alpha is 1 to x, into cos bracket c1 cos beta x means 2x plus c2 sin 2x. This is the complementary functions. And now we find particular integral. This is written like this, d square 2d plus 5, okay, into e to the power minus x. Clear? So here actually polynomial in d is d square 2d plus 5, and now we check, we take minus 1 in place of d, because here a is minus 1, so pa, this is equal to minus 1 whole square plus 2 plus 5, this is 1 plus 2 plus 5, this is 8, which is not equal to 0. So here we have the minus 1 whole square to minus 1 plus 5, and this is not equal to 0. So the particular integral is 1 upon 8 e to the power minus x. Hence the complete solution of given differential equation y is equal to yc plus yp. Yc means complementary function, which is e to the power x c1 cos 2x sin 2x plus 1 by 8 e to the power minus x. Okay, so this is the complete solution of the given differential equation. Some more example on this case we have. Next question is solve the differential equation, and differential equation is, solve the differential equation d square y over dx square plus 3 d plus 2 not d here, dy over dx y is equal to 12 e to the power x. The solution of this differential equation we can write like this. Here we have a non-homogeneous linear differential equation, and right hand side is the function of exponential function actually. So here auxiliary equation m square plus 3 m plus 2 is equal to 0 plus 3. Okay, and the root of this equation, here product is 2 and sum is minus 3, so we can take m is equal to minus 1 minus 2 are the root of this differential equation. Okay, therefore the complementary function yc of this differential equation c1 e to the power minus x plus c2 e to the power minus 2x. And now we calculate particular integral, and this given as, here we have d square, from here we have plus 3d, and from last we have 2, and this operator operate on 12 into e to the power x. Here 12 is constant, so we can take outside to this, and here we have d square 3d plus 2 a to the power x. It is clear when we put here a is 1, and we replace d by a, so here we replace d by 1 and check it is 0 or not. So here we have 1 3 2, it is non-zero, so answer is 1 square 3 into 1 plus 2 a to the power x, and this is 1 plus 3 4 plus 2 6 12 by 6 means 2 e to the power x. Therefore particular integral of the given differential equation is 2 into e to the power x. Hence solution of the given differential equation, y is equal to yc plus yp, complementary function plus particular integral. Therefore y is equal to yc plus yp. Y means solution of the given differential equation, complete solution actually, given differential equation, and this is c1 e to the power minus x plus c2 e to the power 2x plus pi 2 into e to the power x. This is the solution. And now we have some, and now we discuss case second v, and case second when qx is v into e to the power ax, and here pa is 0. So let's discuss on this case. Here actually if we can say that PA is equal to D minus A factor here, because we have PA 0 means we have a factor, okay, D minus A of PD, and remaining, and suppose this is power k into some function fd where fa is not equal to 0. It is clear, if we replace d by a, then pa is a minus a to the power k f of a, this is 0. Okay, so here we use the following formula to find the particular integral of the given differential equations. This is actually PD is here we have write PD into V into e to the power ax, clear, and here PD is actually D minus A whole power k into f of d, and v is constant, so we take it outside, and this operate on e to the power x. Here actually we can replace dy a in fa, because fa is non-zero. Here Here we suppose f is non-zero. So this gives us actually v x to the power k. Here the multiplicity of the factor d minus a is k times, so we take here x to the power k into factorial k and 1 upon f a to the power ax. This is the particular integral. Suppose we have only this factor, okay, so this will be actually this one, e to the power ax. Okay, and now we solve some question based on this case. Okay, so we have some questions based on this case. Question is, solve to the differential equation, and differential equation is d square plus 6d plus 9 y is equal to 2 into e to the power minus 3x. Okay, so we have to solve this. So first of all we find complementary function. We find auxiliary equation m square plus 6m plus 9 is equal to 0. This is actually m plus 3 whole square is equal to 0. This gives us m is equal to minus 3. We have here repeated root. Okay, therefore complementary function c1 plus c2x and repeated root is 3 into e to the power x. This is the complementary functions. Now we find particular integral, and this is d square plus 6d plus 9 2 into e to the power 3x. Here actually 2 is constant, so we can take it outside 2. Okay, this is actually d plus 3 whole square e to the power 3x. Here it is clear that PD is d plus 3 whole square, and we replace d is minus 3, so p minus 3, this is minus 3 whole square, this is 0. Okay. Therefore using the formula, here k is 2, here 2 is as it is, and k is 2 means we take here x2 into 2 factorial e to the power 3x. 2 cancel out, this is x square e to the power 3x. This is the yp. So solution of given differential equation, y is equal to yc plus yp, and y is equal to yc is c1 plus c2x e to the power 3x, and yp is x square e to the power 3x. This is the complete solution of the given differential equations when PA is 0. And next question on this case. This is solve to the differential equation, and differential equation is d square plus d minus 2 y is equal to 3 into e to the power minus 2x. So first of all we find auxiliary equation. Here auxiliary equation is m square plus m minus 2, this is equal to 0. So here actually product is minus 2 and sum is also minus 1. Clear? The roots of this differential equation is actually product is minus 2 and sum is minus 1. So we can take 2 into minus 1. Product is minus 2 and sum is no. We can take like this. Sum is minus 1 and product is minus 2. Okay. Here we have factor plus 2 m minus 1 whole square is equal to 0. You can check on multiplying. We have this equation. So here we have 2 root minus 2 and 1. Therefore complementary function c1 e to the power 2x plus c2 e to the power x. And now we find a particular integral of this equation. So particular integral of this equation is d square plus d minus 2 3 e to the power minus 2x. Here 3 is constant, so we can take it outside. Okay, or actually we have factor of this equation like this, d plus 2 and d minus 1 e to the power minus 2x. Clear? So actually this factor give us PA is 0 and this is the function fd. If we put here d is equal to minus 2, so this is non-zero actually, but from here we have 0. So this equation actually here we solve this like that. First of all we put a is equal to minus a in which factor where minus 2 is not give us 0. So therefore yp3, actually this factor is non-zero on putting d is minus 2, so here we can put minus 1 and this is d plus 2 e to the power minus 2x. So this is actually, this is minus 3, 3 cancel out. We have d plus 2 e to the power minus 2x. Here multiplicity is 1, so we have x to the power 1 factorial and e to the power minus 2x. This is minus x e to the power minus 2x. That is yp is minus x e to the power minus 2x. Clear? So solution of the given differential equation of given differential equation. Actually, given differential equation is non-homogeneous linear differential equation with constant coefficient of order 2. Y is equal to yc plus yp, and yc is here c1 e to the power minus 2x plus c2 e to the power x, and yp is x e to the power minus 2x. Okay, so next we will take the third case when the qx is the product of exponential function and some function of x. Next case is when case C, when qx is v into e to the power ax into some function of x. Okay, here we have polynomial or trigonometric functions. Clear? So here therefore the particular integral of the given differential equation yp 1 upon p d v a x into x. Here actually v is constant, p d e to the power ax bx. Here we replace d by d minus d plus a. D is replaced by d plus a, and we take two exponential function on outside, a to the power ax 1 upon p d plus a, and we solve to this factor. Okay, here we have a operator 1 upon polynomial of d plus a operate on function of x, which is vx. So now we solve some question on this case. So first of all we solve the differential equation is solve to the differential equation which is dqy over dx q plus 3 d square y over dx square plus 3 dy over dx plus 1, sorry here we write y, okay, is equal to e to the power x into 2 minus x square. Here we have v is equal to 1, a is equal to minus 1, and vx is 2 minus x square. So this is the case C, when qx is product of exponential function and some function of x. So first of all actually here we find auxiliary equation, and auxiliary equation can be obtained like m cube plus 3m square plus 3m plus 1 is equal to 0, and it is clear this is m plus 1 whole cube is equal to 0. So here we have 3 minus 1 3 times repetition, or minus 1 is repeated 3 times. Okay. So we know that the complementary function become, in this case here 1 is repeated 2 times, so we take it up to x square, and repeated root is minus 1 into x, this become minus x. Now here we find particular integral 1 upon, this is actually d cube plus 3 d square plus 3 d plus 1, and this operator operate on a to the power minus x 2 minus x square. So it is clear that here we have qx product of e to the power minus x and 2 minus x square. So this can be written as d plus 1 whole cube e to the power minus x 2 minus x square. Now here we take to e to the power minus x outside of this operator, and here we replace d by d plus a, actually what here a is minus 1, so here we replace d by d minus 1. So this will be yp e to the power, here d replaced by d plus a, what here a is minus 1, so d replaced by d minus 1. Here we have e to the power minus x on outside, d replaced by d minus 1, plus 1 is already here, whole cube 2 minus x square, 1 1 cancel out, this is 1 upon d cube, and here 2 minus x square. 1 upon d cube means triple 3 times integration of the given functions. So first integration of this give us 2x minus x cube by 3. Again integrating a to the power minus x 1 upon d, here x square by 2 to cancel out, x square minus x to the power 4 upon 4 means 12, x to the power 4 upon 12. Again integrating to this factor, we have x cube upon 3 minus x to the power 5, and 5 12 5s are 60. So this is the actually particular integral, hence solution y is equal to yc plus yp, and this will be yc is c1 plus c2x plus c3x square into e to the power minus x, plus pi is e to the power minus x x upon 3 x to the power 5 upon 60. This is the complete answer of the given differential equation. And now we will solve some more example on this case. question is next question we have to solve the differential equation is solve to the differential equation which is 4d square minus 5dy is equal to x square e to the power x. So first of all, the auxiliary equation 4m square minus 5m is equal to 0. Here m is 0 and m is 5 by 4. Okay. Therefore complementary function yc for m is equal to 0, c1 e to the power 0 into x, which become 1. So we have c1 into 1, c1 plus c2 e to the power 5 by 4 into x. This is the complementary function. And now particular integral, which is yp 4d square 5d of x square e to the power x. Here we replace a is 1, we replace d by d plus 1. So this will be 4d plus 1 whole square 5d plus 1